TXV capacities depending on orifice size, pressure difference between high and low side, temperature, and conditions of the refrigerant line. These are things that you're really going to have to get to know. You're going to have to get to know how to adjust this. Not necessarily the screw at the bottom, but to figure out whether or not this unit's working. By changing the position sometimes of the thermal expansion valve, you can do more insulation, less insulation. There's a way that you can tweak this without doing a major replacement of a TXV. The reason I say major replacement is you have to pump the unit down. Then you have to take the unit off and the TXV off. Sometimes they're soldered on. Some have mechanical connections, the flared fittings and nuts, but most of the time I would guess you're going to have to unsolder it and put a new one on. Then you have to do that as well as pulling a vacuum and recharging the unit. It's a real pain. It's best to tweak the one you have there if it just needs a little tweaking. Special TXV accessories. And the picture again for that is much better than the one you see on the screen. Refrigerant distributors. Distributing tubes are, depending on the type of system you have, this metering device can have individual tubes coming off it, going to the manifold of the evap coil, or it can have one large tube that it feeds that have holes in it that distributes it different. So in the way of refrigerant lines, it's good to know this information. Out of the compressor, that is considered the discharge line. That's usually 3/8, ½ inch, depending on the size of the unit. But coming out of the compressor is discharge line. When it goes into after it comes out, it goes into the condensing coil. When it comes out, that's the liquid line because it went from a vapor to a liquid, so now that's a liquid line. The liquid line goes into the thermal expansion valve. When it comes out of the thermal expansion valve, it's called the distributing lines. And then when it leaves the evap coil and goes to the compressor, it's the suction line. So it's discharge, liquid, distribution or distributing lines, and then suction line. That you'll probably see a question on. Pressure limiting TXV. Again, this is another item I'm not sure if I've ever worked on before, but the purpose is to prevent overload of the condensing unit. So I'm not sure exactly when I've seen one of these, if I've ever seen one of these, but it's just a little bit more information to you. Mechanical pressure limiter. Here's another diagram, and you can see this in your book probably a little bit easier than you can on the screen. Limits the operating pressure, closes tightly during off cycle, remains closed even when the MOP is reached, the maximum refrigerant, remains closed during pull down, permits rapid pull down, uses with comfort cooling systems and heat pumps indoors and outdoors. This is the time I'm going to mention something. You won't get this until you go into the heating class, but the condensing unit also in a heat pump application has a thermal expansion valve. Because remember, in heat pump mode, or maybe you don't know, in heat pump mode, the outdoor condensing unit becomes an evap coil, and the inside unit becomes a condensing unit. It runs in reverse. And that way you use the hot refrigerant gases instead of just taking the heat out of it outside, you take the heat out of it indoor and it's used as a heating. So we do have these thermal expansion valves on the outside units as well. Automatic expansion valve, constant pressure expands valve, throttles liquid refrigerant to constant pressure, no sensing bulb. Only passes refrigerant when evaporator is below preset pressure level. So this is more of an item that specifically changes the temperature of the coil by changing the refrigerant, but it's automatic. You don't have to worry about it. These are usually only in odd commercial units. I've never seen one in a refrigeration or an air conditioning unit for the home. Just putting this on the table. I've never worked on one of these. I don't think I've ever seen one of these, and I'm not sure what's better about these than others. They give you a list of items, why to use them, and they all seem less than a positive reason to use them. So read up on this, see if you're comfortable with. Not, we can discuss it in for classes or time. Bellows type. Bellows is just adjustment screw at the top that moves it up and down, so you set it. You can go in there later and change it, but you can do that with a fixed metering device. You can change that as well. Diaphragm type. It's, instead of using a pin, it uses a barrier between the pin and the inside of the system, and it's not much difference. It's just a different manufacturer. This has bleeder and bypass valves built onto it. The balance of high and low side pressure during turnoff. This is something that most compressors again have. That way, that compressor doesn't have to start biking uphill. It can start with equal pressure on both sides. Electronic expansion valve. This is one that's kind of like the TXV or the AXV, but this uses electric current to change the opening and closing. More sophisticated, very high dollar units will use these because they're a little bit better than using a sensing bolt to tell the difference. It uses a thermostat and electronic controls. This is one part of the EEV is a stepper motor. It actually adjusts very well, adjusts very minute amounts. It's more like watch consistency than most motors need, but this little motor turns this little tiny cog at the bottom, which turns a bigger wheel, which turns another bigger wheel, which turns a screw. So it's, I have never worked on one. I've seen them, but have never had a problem with the motor. But they are replaceable, so you don't have to take the system or reclaim the refrigerant and recharge and all that. This can be just changed out on its own. Here's information on the controller of the EEV. This is what senses the temperature and sends a signal to the motor to change opening or closing of the valve. This is a post width modulating solenoid for an EEV. This is actually something that is opened or closed. You see these a lot on refrigeration units, mainly rooftop units. So there's no middle ground. It's either all the way open or all the way closed. The float operator refrigerant controls. This uses a receiver to, it determines how much refrigerant's in there, and it can change the pressures of the system because of it. It's another one that's used on very large systems, and I have not had any problems with ones. I've seen them before, but never had to do anything with them. So they might be less problematic as other items. Low side float works kind of the same way. It maintains a constant level of liquid in the refrigerant evaporator, known as a flooded system. Absorbs heat during the on and off cycles, pressure varies with temperature, like any other thermal expansion valve. Here you see the construction of a low side float, and as again you get to look at the picture in the book. It's a little bit easier to see than on the screen, but again, to see one of these out in the field, it's going to be rare for you. High side float, again, shows you how the system works. Again, unless you're working with large commercial systems, you won't see one of these. Weight valve. needed if a capillary tube is not used between high side, float, and evaporator. Components are a weighted needle, adjustment spring, valve seat, inlet port, and outlet port. Produces pressure drop for the evaporator, like all the metering devices do. Here's a diagram of the high side float operation. Again, something you probably won't see a lot in most modern refrigeration unless you're working in large commercial units. This is our last slide, and remember, these PowerPoint presentations are not a substitute for reading your manual. It's very important. Your textbook has a lot of information in it that are not covered in these slides, and you need to read it carefully so you do well in the future, not just only on your tests.